Okay, we're going to take a look at question 97 from section 9.1, which is radical expressions. 97, what we're asked to do is we are asked to graph a function given a transformation. So the function that we're provided in 97 is f of x is equal to the square root of x plus 4. So to begin, I'm actually going to write some side notes in blue. We want to know what the parent function is. So the parent function is pretty much the function that we would have if we didn't have any sort of bells and whistles. And when I say bells and whistles, I mean any sort of transformations like shifting up or down, left or right, or reflecting our function over the x-axis. So what I have written in blue, f of x is equal to the square root of x, is our parent function. Okay, so to begin with, we can go ahead and create a list of points, and we can graph this parent function so that we kind of have an idea of what the shape should look like for a square root function. Okay, so note from section 9.1, we cannot take the square root of a negative number in this case, okay? It's a non-real number, or what we will soon find out later in section 9.7 is that it's an imaginary number, or a complex number. So I really can only start with x being equal to 0. And from there, if I put 0 into the function, my y value would be 0. If I put 1 into the function, the square root of 1 is 1. And then I'm going to be deliberate here. I'm going to pick 4, because the square root of 4 is going to be 2, and if I'm feeling ambitious, the square root of 9 will be 3. So if I were to plot this, and I'll plot this in red, so here's 0, 0, 0.11, 0.42, and then 0.93. So my function curves upward, okay, and it's going to continue to climb in that way. So now what we're going to note is we're going to go back to the function that was supplied to us in the problem, and we see that there's a plus 4 inside of the root. So think of it in terms of being inside the house. So in this case, if it's inside the house, this is going to be a horizontal shift, so I will move left or right. And since I'm inside of the house and I see a plus 4, I want to do the opposite. Remember, it's like a house of lies. So we're actually going to move to the left 4 units. Okay, so we'll go ahead and we'll note it down here. Okay. So if I'm moving to the left 4 units, that means that I am changing my x value since I'm moving along the x-axis. So what I'm going to do is I'm going to subtract 4 from all of my x values, and this will update my coordinate points. So now I will have a point at negative 4, 0, I will have a point at negative 3, 1, a point at 0, 2, and then a point at 5, 3. So we'll go ahead and we'll note these points in purple. So negative 4, 0, negative 3, 1, 0, 2, and then 5, 3. And as you guys can see, the function that I have outlined in purple here looks pretty identical to the one that I have in red in the coordinate plane above. The only thing, if you notice, is that each of those points have been moved to the left 4. So this is my final solution. The one other option, or the one other question that they do ask you is to note the domain and range of the function that you graphed. So recall that domain deals with what x values you use in order to graph the function. So if you notice here, it looks like my graph kind of comes to life from negative 4 to positive infinity. And I use a bracket next to that negative 4 because I have a point that is using the negative 4x value. Okay, and then for range, this deals with our y values, and it looks like we start using y values at 0 to positive infinity. If you notice here, the -4 in the domain and the 0 in the range, this is also the starting point of your transformed graph. Okay, something to think about. All right, and this is number 97.